a 0.00, so a 6.12 kilogram rest mass bullet is going so fast it is dilated to this mass. Okay, sorry. What's its total energy and what is its velocity? Okay, so the total energy basically is the kinetic energy. Remember, is basically the dilated mass minus the rest mass times c squared, right? So this is easy. We can just go. The dilated mass is 0.00645. The rest mass is 0.00612. We're going to multiply by 3.00 times 10 to the 8th meters per second, and don't forget to square it. Oops, I put units on by accident. Okay, so understand what we're saying here is that the reason that the mass changes is that it's got kinetic energy, right? Okay, so if you find the difference between, if you take the amount of mass that it increases by and multiply by c squared, we're just using Einstein's E equals mc squared, okay? All right, so I'm going to go 0.00645 minus 0.00612 times 3 times 10 to the 8th squared. And I get that the kinetic energy is equal to 2.97 times 10 to the 13th joules. So that's, and there's no minus sign there, that's just a stray pen flick there. So that is its energy. How fast is it going? Velocity is going to be c times the square root of 1 minus small quantity squared over big quantity squared. Okay, so let's see. So it's going to be c times the square root of 1 minus 0.00612 squared over 0.00645 squared. Be very careful that you use the whole rest mass, the whole dilated mass for this. Okay, so let's see. Square root of, and I'm just going to leave it in terms of c, so I'm not going to actually multiply by c. So 1 minus 612 squared divided by 645 squared. And I get that it's 0.3157 C. I think we might only have 2 sig figs because I think when you subtract those two, you only get 2 digits. Okay, so 0.32 C is based on 2 sig figs. If you thought you had 3 sig figs, you'd say 0.316. I know that probably is just terribly engaging for you. Sorry.